Hello everybody. Today our lesson will be on analyzing the graph of the derivative. So over the last couple of days we have been studying the relationship between f of x, f prime of x, and f double prime of x, algebraically. Today we will be discussing how to analyze the relationship between these three functions graphically. We're going to do a little background right now. So we're going to do a little warm-up. If f of x equals x squared, find f prime of x. And I want to sketch both f of x and f prime of x. So if f of x equals x squared, I know f prime of x is going to equal 2x. And I can sketch x squared really quickly. By sketch, I mean simply this. There's my x squared function. Okay, we all know that. So f prime of x, or the derivative of this function, if we were to graph it, would be the line 2x. So my y-intercept is 0, my slope is 2. So I have a line that looks something like this. Okay. So let's just real quickly talk about the relationship between these two curves. For instance, notice when the original function is decreasing, the graph of the derivative is below the x-axis, and when the original function is increasing, the graph of the derivative is above the x-axis. So that, those are the concepts we're going to use today when we analyze the graph of a function using the derivative. Just real quickly before we move on, what if I wanted to find f double prime? F double prime of x equals 2. Okay. 2 is just a number, it's a constant. Its graph would just be that line, right? That's my second derivative. However, more importantly, what do you notice about this number? F prime is a positive number, right? 2 is positive. So that tells me that the original function is concave up. And if we go back, our original function is concave up. So again, we're going to be connecting these concepts today as we analyze the graph of a derivative function. Let's summarize the relationship real quickly. If f prime of x, okay, if we're going to talk about these things, we're going to be describing f of x. So when f prime of x is greater than 0, we know our function is increasing. When f prime is less than 0, the function is decreasing. And when f prime of x is equal to 0, well, that's when we have any maximum and minimum values in our graph. And we're going to have a relative maximum value when f prime is 0 and goes from positive to negative, or if we're looking at the graph of the function, it's where it's above the x-axis to below. And our minimum value is, again, where the derivative is equal to 0, goes from negative to positive on a number line, but if we just want to use the graph of the function, it's below to above. Okay. I'm going to show you both ways when we get to an example, but I just want you to remember these facts. Now with our second derivative, what does that tell us about our function? When the second derivative is positive, our function is concave up. Second derivative negative, our function is concave down. And we know we're going to have a point of inflection whenever the second derivative changes sign. And if we're looking at the graph, they're going to be the maximum and minimums of f prime, okay, or the turning points. And again, as we move through the lesson, I'll try to help you out with some of these things. One last little point here. When the second derivative positive, that's when f prime is going to be increasing. And when the second derivative is negative, that's when f prime is going to be decreasing. Okay, this is going to be if we're looking at the function, at the derivative itself. Okay, so now let's kind of try to work through an example together to see how all this is put together. And I will tell you, it's really not that difficult. Okay, so we're going to start with our graph of the derivative h prime of x. It's a function of h of x, and it's pictured below. Identify the characteristics about the graph of h of x. We're not going to worry about the reason for our responses. We're going to kind of list them, but we don't have to worry too much about the words right now. We just want you to be able to analyze the picture. Okay, so if I want to find the intervals where h of x is increasing, decreasing, and maxes and mins, I know I'm going to be looking at the first derivative. So I can make myself a number line for the first derivative. And how am I going to get the critical values? Well, they're going to be where f prime equals 0. F prime, h prime, I'm so sorry. Okay, we're looking at the graph of h prime. So these are going to be my zeros. Anytime the graph of the derivative crosses the x-axis. So I have -2, 1, and 3. So these are where the derivative equals to 0 or my critical values. Now I need to determine where the graph of the derivative is positive or negative. Well, the graph of the derivative is positive here and negative here. Okay. Remember, I don't have functions to plug values into. I have to analyze the information right from the graph itself. So in my interval, if I had an algebraic function, I would plug a number in. Instead, I look at the picture. The graph of the derivative is negative. The graph of the derivative is positive. The graph of the derivative is negative. The graph of the derivative is positive. So if I want to determine the intervals where the h of x is increasing, it's going to be increasing on the interval -2 to 1 and 3 to infinity. I just want to point out here, sometimes I will give you a closed interval, in which case it will stop at some point. When I do that, you want to make sure you include that number as your end number and use a bracket for that. Now let's talk about the intervals where h of x is decreasing. Well, it's going to be decreasing when what? It decreases when f prime is negative. F prime is negative from -infinity to -2 and from 1 to 3. Let's talk about if you didn't want to use a number line. Let's say we just wanted to look at the graph itself. Well, then I would be looking for where the graph is below the x-axis. And I should mention that above here too. This is where it's above x-axis. In other words, where f prime is positive. Okay? Values where h of x has a relative maximum value. Values of h of x where h of x has a relative minimum value. Now remember, for a max, we're looking on our number line from plus to minus, or we can look where the graph goes from above to below. So if we use our number line, that value is going to be when x equals 1. Now remember, I cannot get a y value for the function. I could not get the point because I don't have an algebraic function to plug into. Where does the values of x where h of x has a relative minimum value? Well, that's going to occur on our number line when I go from negative to positive, or when my graph goes from below to above. So we can clearly see that those x values are at x equals -2 and x equals 3. Now remember, we cannot get y values. We can't describe points here. We can only give the x values. Now, where's the graph concave up and concave down? Well, now this gets a little tricky. Okay, so now we have to analyze h double prime. So how do I analyze h double prime? Well, if I'm looking at h prime, h double prime is going to be the slopes of the tangent lines. So wherever the slope of the tangent line is 0, that's when f double prime is 0. So this is going to occur when x is -1 and when x is 2. Okay, so that's how we find the so-called critical values of the second derivative. So now to get the signs, we're going to use slopes. Okay, so if I draw slopes in each section, here, f double prime, or my slope is positive, my slope is negative, my slope is positive again. So in this section, this interval, I have positive slopes. In this interval, I have negative slopes. And in this interval, I have positive slopes. Now, some of you may prefer to describe it this way. The function is increasing. So h prime is increasing. I used f prime. That's okay. We know we're talking about the same function. So h prime is increasing, h prime is decreasing, h prime is increasing. Some of you may prefer that method, and that's perfectly fine to use. Intervals where the h of x is concave up, remember, that's going to be where h double prime is positive or where h prime is increasing. Intervals where h of x is concave down, h double prime is negative, or h prime is decreasing. So now we're just going to describe those intervals, and h prime is going to be concave up from -infinity to -1, and from 2 to infinity, and h is concave down from -1 to 2. And lastly, we're going to talk about points of inflection. So these are going to be any sign changes on our number line or turning points on the graph. Okay, so when we go back up here to look at this for a minute, I see it happens at -1 and at 2. And again, we see our turning points. So our points of inflection are -1 and 2. Okay, so now we want to try to draw a possible sketch for h of x. Okay, this is not going to be so easy for some of you, but give it a shot. Okay, we're just going to talk through this really quickly. I'm not going to ever make you do this on an actual test itself, but you may have to pick one from a bunch of different choices. Let's break our number lines up and kind of describe what's going on here. When x is less than -2, my graph is decreasing and concave up. So I'm kind of going like that. At -2, I have a minimum value. Okay, that was from my work below. Now my graph is going to increase and be concave up to -1. When x is -1, I have a point of inflection, which means my graph now, even though I'm still increasing, I'm concave down. When x is 1, I'm going to have a maximum value. So I'm going to turn around in the graph of the function and start decreasing, but still concave down. At 2, I change concavity. I'm still decreasing, but I'm concave up. At 3, I have a minimum. So I'm going to turn around and start increasing again and be concave up. Let's just sort of all we're going to do right now is take this information and kind of move it over here. I don't have any real y values, so I'm going to just make these up. -2, -1, 1, 2, 3. Those are some important places on my graph. So at -2, I know I have min. I'm going to put that here. At 1, I have a max. I'm going to put that up there. At 3, I have another minimum, so I'm going to go down here. Why not? And we're just going to, at -1, I have a point of inflection. And at 2, I have a point of inflection. Our graph isn't going to be pretty, but we're going to try to trace along. So my graph is decreasing, concave up, increasing, concave up, increasing, concave down, decreasing, concave down, decreasing, concave up, increasing, concave up. So this technically is one version of a graph of h of x. Again, I'm not going to test you on that, but it's something that you should try to do on your homework. All right. Before we end today, let's just take a quick look at a different way we can ask these types of questions. So this is an AP style question. It is a little challenging, but I think you guys can handle it. Suppose the graph of the derivative is shown below. Okay, so we're looking at the graph of the derivative. We want to figure out which of the following could be a graph of the original function. So when we look at the derivative, what are some things we can say? Well, this derivative is positive, right, over the entire domain, which means f of x is increasing. This helps me rule out a couple of choices. I can rule out choice A, choice B, and choice C because these graphs have increasing and decreasing intervals. So now I'm left with the last two options, D and E. These are both increasing over their entire domains, but their concavities are changing. So in order to analyze concavity, we need to analyze the second derivative. So I'm going to identify where f double prime equals 0. Now I see that f double prime is greater than 0, right? When x is less than 0. So this means my function is going to be concave up. And I see that the slope of the tangent line here is negative when x is greater than 0. So my function is going to be concave down. So now I'm going to look for the picture that goes from concave up to concave down, and I can rule out D. So the answer is E. Thank you for your time today. I hope this made sense to you guys. Give a little shot at your homework tonight and enjoy your Easter break. So long.